because the powers are the same. So I get the absolute value of x, and I need that to be less than 1 to converge. And so my radius of convergence is 1. This also gives me an interval of convergence of -1 to 1. But I like to do this. But is it less than? Both times, why did the video just get like darker? Hello, it just turned off.
It's still on. Oh no, it's
No,
not.
it's
Oh, it said
not.
it's definitely still recording, but we're good.
Hey, everybody, just hang loose.
We're good.
Okay, we're good. So this seems like a little thing, but like, so we know it converges from -1 to 1, but what happens at -1? Just like Busani was doing up on her whiteboard work, what happens at the endpoints? So we have to check convergence at the endpoints, and I'll tell you why right now. Like here is a sample question on the test that you may or may not take for us at some point, if and when we come back to school. The question for, or even on an AP exam, which we're convinced is going to happen, the interval of convergence. Your answers are going to look like this, and this is so sad. You're going to be so sad. What am I missing here? Right? So the AP exam has gone to 4 answers, not 5. Otherwise, the 5th answer would be none of these, and you would know that was wrong because, really, seriously. So one of these answers is right. You don't even have to actually do this work if you're doing an AP exam that's multiple choice, because you know it's going to be one of these 4 answers. All you have to do is check the endpoints, and that's what I have to teach you how to do. So checking the endpoints is like this. What happens when, can you see this color? When x is, wait, I'm looking to see if that's a bad color. Probably it is. I'm going to black. I don't like it, but I'm doing it.
It's good.
When
Yeah,
x, oh no, yeah. When x is equal to 1, does this series converge or diverge? This is going to feel just like the test that you took. So when x is equal to 1, we go into the series, and from n equals 1 to infinity, plug the 1 in here, you just get 1 to the n. 1 to the n is 1 over n. Busani, get off your phone. What does this series do?
That's the harmonic series. It diverges.
Okay, so remember how you, okay, first of all, I finished grading your tests, and I finished grading them way before Monday, and she finished grading your tests yesterday. We can't give them back to you, but we have like written all kinds of comments on your tests, and we know you haven't gotten feedback on that, but like on your test you had to write really specifically like, why does this diverge, why does this converge? We're done with that. It's over. We don't care anymore why, very much. We'll say it, but we're not going to write it. We're just going to be like, it diverges, okay? For today, I'm going to say why. It diverges because it's harmonic. And I'll say it, but I'm not going to write it anymore. Or we're done with all that garbage. So if it diverges because it's harmonic, what that means about this endpoint is it's not in the interval of convergence, and that means this inequality is going to hold true, and if that inequality is going to hold true, then these are not the answer, because it's not converging at 1. Does that make sense? Got my audience members? Okay. So now I'm going to do what happens when x is -1. When x is -1, I have, again, up here, -1 to the n over n. So you did a ton of work on your, recently on alternating series. This is an alternating series. And so here are the steps. You take the limit, it's 0. You look at the absolute value, it diverges for the same reason this does. And then you go into your alternating series test, step number 2. And do you want me to show them that? Because it's going to...
No, you guys know that the alternating
Alternating
harmonic series converges, right?
I hope so. So I don't know how much detail they want, but that is an alternating harmonic, and it diverges by the alternating series test, right? Does everyone remember that?
Go look it up if not.
Okay. So what that means then is that at this endpoint it does converge. It actually converges conditionally, but that's not really going to matter because we don't have options for how to like write different kinds of brackets for that kind of convergence. But it converges conditionally, which means I have to add in an equal sign right there, and that means I have found my answer, folks. Right? So, of those four that looked exactly the same, the one that is right is where it converges at the left and not at the right. Okay. That took longer than I thought it would. Shall we do another one? Do you have something
Yeah.
to say? You want to say something?
No.
Are you sure? Mm-hmm. Okay. Because if I'm ever not clear, you got to tell me. Okay, I love this one, and I will tell you why I love this one. Do you know why I love this one, Rusani?
No.
Really?
Really?
Okay, I'll tell you. What kind of series is that?
Oh, it's geometric with x plus 1 over 2. No, it's alternating.
I like the first thing you
It's-
said.
Yeah, it's geometric with x plus 1 over 2 as your r.
Okay.
And it's also alternating.
It is alternating, but
It
if
doesn't
we do
matter
the
because we can do absolute.
Yeah, for absolute convergence, we just knock that out and we don't deal with it. So this is a geometric series. R is equal to, I don't even think I need to say that. So geometric series, it converges for the absolute value of 1, x plus 1 over 2 less than 1. Okay, what class is it that you guys learned how to solve absolute values? I wonder if you remember how to do this. So let's remind you how to solve this. So we're trying to figure out the interval of convergence, and the first thing we can do is multiply this by 2. Leave the absolute values. Multiply by 2. I was going to say on both sides. There aren't both sides. They're about to be. Now, to get rid of these absolute values, I'm going to change it to the definition, which is this. Note, the center of this polynomial is -1 because the center is always x minus a number. So what number? X minus -1. So the center is -1. This is not my interval of convergence. I need to subtract 1 from all the sides, if you will. That gives me -3 is less than x is less than 1.
And I'll just interject here. Actually, you won't remember this, but if you did take Advanced Algebra 2 from me, I gave you a test on this where I asked you to write this in English. And you had to write something like, the difference between x and -1 is less than 2. And then just by saying that sentence, you're right here. Right?
Oh, cute. So and when I teach Algebra 1, which I don't do often anymore, I would say the distance from a number to -1 is less than 2. So the distance this way is less than 2 gives me, I can't do math, 1, and 2 this way gives me -3. So we're talking about all the numbers whose distance from -1 is less than 2 units away, right?
Mm-hmm.
Okay, so
What a nice interval and radius.
I know. So wait, what is the radius?
Radius looks like 2, huh?
Yeah, so that's radius of 2. And the interval is this, but you know what? I want to stop there and just say we're done. How can I stop there and say we're done without checking my endpoints?
Well, because geometric series don't converge when r is equal to 1.
Yes, so that's a fat no. We don't need to check, so no need to check endpoints for geometric series.
Going downhill.
I'm going downhill. I do this all the time. Now, welcome Busani students to my impossibly not flat handwriting that happens every day. No need to check endpoints when, there's also a glare on that.
Yeah, it's
Whatever, sorry guys, sorry. You just have to listen to my words. No need to check endpoints when geometric.
You put on your primer today, right?
I spent hours on this face. Bronzer.
Oh, primer first, so you
I don't
don't
even
glow
know.
under the bright lights.
I don't own any of those things.
I heard that makeup tutorials are really popular on YouTube and we're going viral this year, so
Our
I'll
next
just give you a
video-
couple of hints about using primer when you're going to take flash photography. Really have it on there so that it doesn't.
The glare.
The
You can
glare.
eliminate the glare.
That's right.
Do I have glare? Well, I have words like all over my face that I can see that must be super annoying if you were a student. Okay, so that's why, in summary, I put the heart next to this is because it was geometric, and so I was like, yes, I do not have to check my endpoints because checking endpoints can get a little cumbersome.
Cool.
Anything else you want to say about that?
No, just that if you do forget that you don't need to check endpoints, it should be really pretty easy to check them by looking at like -1 to the n and 1 to the n in the same way that I did in that first one.
I lost my equation, but, oh, there it is. Do you want me to do it?
No.
Okay. So, oh, sorry. So, like, yeah. I'm doing it, kind
It's
of.
to the n.
Oh, this whole thing.
Something like that.
Yeah, so is this, oh, yeah, we'll address this. It gets
But like,
tricky.
right, so like clearly at the point where this is 1, it's just 1, it's that thing.
It's 1
and
to
then
the- yeah.
when it's -3, it's -1. It's actually just like the sum of ones, and both of those diverge.
Yeah.
But one of them equals 1/2.
Oh, she's fixated on the 1/2. Okay. My class, we just said,
More?
we said this, oh, there's,
Oh, you already did.
no, there's more. Should I do more?
Yes.
Okay. You remember, you're sitting at home with nothing better to do. You should watch this. This is good times,
I know.
right? Why wouldn't you be doing
And
it?
sometimes there are like tips sprinkled in for other facets of your daily life.
You never know when you're gonna get a makeup tip. Okay, well, let's get you involved in this again. So
Great.
because I clearly don't know
I think you're doing it amazing.
what test would you like for me to use? Are we gonna do the ratio again?
So it seems like we probably can. I was thinking that we didn't want to do the ratio test because of the n+1 squared, but if we just stack the n over the n+1 and put them all squared, then I'm okay with that. So yeah, let's do ratio test again.
Ratio.
Wow, it seems like ratio test is really coming up a lot in these.
I love the ratio. It was one of my favorites.
Hope you guys learned your ratio test on your test.
Well, if you didn't learn your ratio test, then
That's true.
you will. And
Right.
the other thing that's coming up a lot, or will come up a lot, is that alternating harmonic and the alternating and just the regular harmonic. So hopefully you have got those down. So cancel this, we get x, and then we have an n squared. Think for a minute while I'm writing, what is that limit of the n things? So I don't feel like multiplying that out, right? That's going to be an n squared on the bottom, that's an n squared on the top. There's an x that's just a 5 or a number. And so what's this limit going to be?
X.
Okay, this is 1. X times 1, so you get absolute value of x less than 1. You are going to see so many, for some reason, so many of these are going to be less than 1. So many of them will have that interval. So the interval of convergence, again, is going to be from -1 to 1. But again, you have to be like, are we sure about those endpoints? And so we're going to check them.
Woo!
Okay, let's check
I see
them.
what's happening.
What?
I get it.
Oh, good. So when x is equal to 1, our series is 1 over n squared. Is there a name for that series? On the wall? On the wall. Look on
God.
the wall, everybody.
Why didn't you guys take the wall home? You can't see this, but it doesn't matter. You know what it is.
You have the wall memorized. You guys know it.
Got it.
It's a p-series. Is it a converging or a diverging p-series?
It converges because p is greater than 1.
On my test, I made them write p is equal to 2, greater than 1, and they did not like that. Okay, so that means that I can change this to, what was that, this one, to less than or equal to. I'm going to erase that then. We're going to be here all day. Okay, and then x equals -1 to the n over n squared. Quick, what happens to that one?
Well, it already absolutely converges, so that was silly.
Are you insulting me?
No.
Converges? It converges absolutely. Well, that's dumb, yeah. So, by the p-series test. So we're going to add that baby in, and our interval of convergence is going to be a closed interval. Any questions? Okay. Wait, I think there's more. Let's see.
Hey!